So the title of my session is Wi-Fi 7 worth it? If you go and Google, is Wi-Fi 7 worth it? You will come up with opposing views. So the New York Times says, no, you do not need it. But some others more or less say it's life-changing. It will offer significant improvements in speed, efficiency, and security. Those are all good things. So let's see, what is it? What is it actually? Where does it land? So here is where I think we are in the adoption phase. I believe that we have crossed the chasm and are exiting the early phase of Wi-Fi 7. So, 2025 is the year where we have seen, started to see mass deployments of Wi-Fi 7. But, if we look overall at the, there's a lot of Wi-Fi out there. So it's, Wi-Fi 7 still makes up a minority, less than 10%, less than 5% of overall installed Wi-Fi. So it'll take time. It'll take time to, to grow. And, we saw a similar kind of thing with 6 gig. So I have to start with just kind of level set, where do we think we are with Wi-Fi 7? And so today, the Wi-Fi 7 client adoption is about 5 to 10% of overall clients in a Wi-Fi 7 deployment. If we contrast that with Wi-Fi 6E, today we see anywhere from 20 to 70% Wi-Fi 6E clients, depends on the environment. If it's a, bring your own device type of environment like a university, that could be 20, 30, 35%. If it's a corporate type of environment where the employer is issuing devices and they've moved to 6 gigahertz devices, that adoption can be very high. It can be 70%, sometimes even higher. And so that it hasn't always been like that. If we go back 3 years, Wi-Fi 6E was in this 5 to 10% range. So it'll take another 2 or 3 years for Wi-Fi 7 client adoption to grow. There's another one in here around, how many radios have 6 gig turned on, and I have some more data, but this is a kind of a pet project of mine to get the 6 gigahertz adoption turned up. So today we're at about 60% of all of Juniper Mist Wi-Fi 6 or 6 gigahertz capable access points. So that could be a 6E or a Wi-Fi 7 AP. About 60% of the radios are turned on, which was 50% a year ago, 30% 2 years ago. Time for a little history. I'm not going to really do history, but the point of this slide is, the last almost 30 years of Wi-Fi, there has been a lot of innovation in Wi-Fi. It's actually, the thing that I probably enjoy the most about Wi-Fi is there's still a lot to solve. There's a lot of things that we haven't figured out, a lot of things that we can do better. And if we look the last 4 or 5 generations of Wi-Fi, we have settled into a 3-year cycle where every 3 years now we're getting a new generation of Wi-Fi, pretty much like clockwork. We're starting with Wi-Fi 5, 11AC Wave 1 in 2013, and then 11AC Wave 2 in 2016, Wi-Fi 6 in 2019, Wi-Fi 6E in 2022. We had a kind of a half generation Wi-Fi 6E to Wi-Fi 7. It was only 2 years. And caused a little confusion, I think, with people of, hey, should I actually just wait for Wi-Fi 7? And now that we have Wi-Fi 7, we're in the, should I wait for Wi-Fi 8? And the answer is, in my opinion, we're in this kind of regular cycle every 3 years. You deploy, whatever is current, because there's always something new coming. And this 3-year cycle, I think, is a little too fast for some people. Certainly, the industry can't keep up with it. I think, there's some pretty major things between these generations, and it takes time to prove them out in real deployments. And so with this, 3-year cycle, things are kind of getting left behind. So I think we have now proven out 6 gigahertz. We know it works. We know clients connect. But now we're in Wi-Fi 7, and we're still figuring out things in Wi-Fi 7. So let's talk a little bit about Wi-Fi 7. How do we end up with a Wi-Fi standard? Well, probably everybody knows it starts with the IEEE. So within IEEE, there's 802.11 working group, and within 802.11 we have 802.11be. And so I've made a Venn diagram of how we end up in our an access point that's actually broadcasting a Wi-Fi 7 SSID. So from IEEE comes in Wi-Fi Alliance. Wi-Fi Alliance has a Wi-Fi 7 program. Within Wi-Fi 7, it's taken the work that IEEE has done. So IEEE is defining the specification and how things should be implemented. Wi-Fi Alliance is saying, yeah, we're going to take these. This is what we really care about. This is what should be mandatory. This is what should be optional. And if you want to be a Wi-Fi 7 device, this is what you must support, or maybe support, mandatory or optional. And so that's always sort of included, PHY level and MAC level features. But most recently, there's also security built into Wi-Fi 7 or built into the major Wi-Fi programs, which is the right thing to do. No longer is security sort of like outside of the outside of the scope of a Wi-Fi generation. It's in a Wi-Fi generation. There are Wi-Fi security requirements, to keep the security posture of Wi-Fi good, right? That it makes total sense. Now that also introduces friction in terms of adoption, and historically security has been, I think, one of the thing that scares people the most around around turning new things on. Like if you think about Wi-Fi 6. You just turned on Wi-Fi 6, you didn't have to do anything else. With Wi-Fi 6E, we had WPA3, and there's even more requirements for Wi-Fi 7. And I think that's what is one of the things that has slowed adoption a little bit of some of these newer technologies. So we have Wi-Fi Alliance. It's done its job of, hey, this is what we're going to support. This is what's mandatory, what's optional. And then the vendors come along, whether it's a chipset manufacturer, client manufacturer, AP manufacturer, says, all right, yep, this is what the standard says. This is what we're actually going to go do. This is what we're going to implement. This is how we think our customers can actually leverage these types of features. So that's how we get from the very beginning with IEEE into an access point that's actually broadcasting a Wi-Fi 7 SSID. There are a lot of other presentations that will go more deep into the individual features in Wi-Fi 7, but at a high level, I think these are the things that we've ended up caring about. There's certainly more to Wi-Fi 7 than these things, but 4K QAM, we're a little on the fence about in terms of can you actually maintain these data rates, and I think largely it's turned out yes, you can. 320 megahertz wide channels, we probably don't really care about those, but it's a thing. Multi-link operation is probably the biggest feature in Wi-Fi 7 that people are most excited about. And as was said earlier, I think it's one thing that we probably have to learn the most about still. And then there's other things like preamble puncturing, multi-resource unit, which are nice, but come with their own sets of caveats. And then from a security perspective, we have WPA3 is mandatory, GCMP 256 mandatory, group-dependent hashing mandatory on personal SSIDs, beacon protection. And so it's not just the 5 features anymore. It's security that comes along with new generations of Wi-Fi. And if we look, Wi-Fi 6 and earlier, right? There's really no dependencies around security. Wi-Fi 6E said, hey, you have to do WPA3 on 6 gig, no more open, you have to do OWE. Wi-Fi 7 takes that a step further. On any Wi-Fi 7 BSS, you have to support WPA3, GCMP 256. There's quite a few things. And so Wi-Fi Alliance, I think, has done a very good job of setting a guidelines and rules for Wi-Fi 7. And so everybody's going to follow these rules, right? So, well, we live in the real world. So this is a Wi-Fi 7 client connected 802.11be, but the security, well, I don't have my spotlight, is CCMP, right? That's not allowed. We just went through and said, you have to have GCMP 256 if you're a Wi-Fi 7 client. Yet it's doing it, right? It's working. It's advertising Wi-Fi 7 capabilities. This is what it's actually supposed to look like, right, with GCMP 256. So yeah, we have the rules, and I think what we're seeing in Wi-Fi 7 on both the access point side and the client device side is there's some leniency in terms of prioritizing compatibility over strict adherence to the requirements. And I don't necessarily think that's a bad thing. Think about your parents, your grandparents. They go out and buy, maybe on your recommendation, they go buy, a router for their house, and their clients can't connect. Well, what are they going to do? Either they might call you up, maybe they're just going to return it. And so I think that's kind of where we are. Is yes, we have these new security requirements, but we also want to make sure that our networks still work and clients connect. But that's not to say, hey, we can't make progress, right? I think that the progress is made. So if I look kind of at just some numbers, right? In terms of if we look across configurations in Mist of our Wi-Fi 7 capable APs and Wi-Fi 7 SSIDs on Wi-Fi 7 capable APs, almost 100% have Wi-Fi 7 enabled. This is a default feature in Mist. Wi-Fi 7 enabled. This may look different in other vendors with, different vendors have different defaults. If you look at, I think, Cisco and Aruba, Wi-Fi 7 is disabled. Now, this is a bit of a misnomer because, right now we, Juniper Mist, do not have the Wi-Fi 7 security modes enabled out of the box. That will soon be enabled. But it's very easy and very safe. What we have found is actually to turn on Wi-Fi 7. And so, if we go a little bit deeper, 320 megahertz wide channels, 0.1% of our APs are using 320 megahertz channels. And I have 2 of them at my house. I'm doing dual 6. I think that substantially skews the numbers. Multi-link operation, like 3%. So we have some features and we have Wi-Fi 7, but are we able to use these features? I think that's another question. Now this will change over time. Now I also need to say one other thing. Here's a screenshot from an Aruba AP. Now this is a client doing MLO. Why am I showing this? Well, look at this. MLO on 6 and 2.4. I don't know. I think this is the biggest farce of Wi-Fi 7. Yeah. So, is there benefit to this? Maybe in some environments. I don't know about you. In most of my customer environments, 2.4 is shot to heck. This won't really help. Maybe it'll opportunistically give you some improvements. And I also think the good thing is this is an early Wi-Fi 7 client kind of behavior. It's cheaper. It's easier to make a client that can have multi-link on 2.4 and 5 or 2.4 and 6. You need a higher end device, more expensive, RF design to be able to support multiple bands and the high band simultaneously. But we're seeing a lot more of the recent types of devices actually support multi-link simultaneously on the high bands, 5 and 6. Now, from a security perspective, if I look across all of the associations in Mist, right, billions and billions per day, 50% are WPA2 personal today? %, WPA3 personal. On the enterprise side, 36% WPA2 personal, 9% WPA3. 36% WPA2 enterprise, 9% WPA3 enterprise, and 4% OWE. Why is WPA2 50%, right? This is like, that half of the connections are WPA2 personal, but only 1% are WPA3 personal. Like, how do you go from something that is so commonly used to like almost a rounding error? I don't know. I don't have a good answer for that. What I can say is when you turn on WPA3, clients use it. So in 2021, we would typically see about 80% on a WPA2, WPA3 transition SSID, 80% of the clients on that SSID would connect with WPA3. Then in 2022, that went up to about 90%. In 2023, 98%. 2024, almost 100%, 99.5%. So if you turn on WPA3, clients will use it. I think we've come into, there's a lot of perception around compatibility, and certainly there have been and are compatibility issues with WPA3 personal. But things progress, right? Clients get better, and largely, majority of clients, certainly the most common ones out there, just do WPA3. And so we have this kind of, I think, head of line blocking of, it's like chicken and egg. So, this leads me to my soapbox, which is, I think as an industry, we are in a mode of, hey, we're putting out new generations of Wi-Fi every 3 years. We have these new security requirements, and all this is important, right? We have to keep making progress, but at the same time, the real world doesn't move that fast. And so, for me, the big thing over the last few years has been 6 gigahertz. Let's make 6 gigahertz and make sure it actually works in real deployments. And now I think that's proven out. And so the mission now is Wi-Fi 7 is larger mass deployments of WPA3. And I think we'll get there. But the thing that to me that makes it the most difficult is, we're coming out with these features and abilities in the standards, but can't necessarily turn them on by default, right? 3% MLO, why isn't that everybody turning on MLO, right? Or as a vendor, I don't necessarily feel comfortable with MLO as a default feature, right? Because of potential interoperability issues or unknowns. And so I want to get to a point where, hey, how do we actually make that a default? How the things that we're coming out with in standards, how can we ensure that those are actually, you can turn those on by default, out of the box? Maybe that'll be Wi-Fi 8, I don't know. Maybe it'll be Wi-Fi 9, Wi-Fi 10, who knows? Anyway, that's my soapbox. As they say, it's all about the 6 gigahertz, baby. This is a lyric from Weird Al Yankovic, probably. I think it was actually, it's all about the Pentiums, baby. Which is a parody of It's All About the Benjamins. Anyway, from a 6 gig perspective, this is what we see year over year. Of the 6 gig capable APs with 6 gig enabled, so that's Wi-Fi 7 and 6 gig APs as well. 2023, people were 30% of people that bought a 6 gig AP actually turned it on. In 2024, it's about 50%. This year, it's about 60%. Now, the most encouraging thing is if we look at just Wi-Fi 7 APs, 75% of our Wi-Fi 7 APs have 6 gig turned on, which means that like it's once you go deploy something, you configure, you're not likely to change it, right? So it means in new deployments, we're seeing most people turn on 6 gig, which is good. That means those people are turning on WPA3, which is also good. From if you want to, how do you get to Wi-Fi 7? How do you get to Wi-Fi 6E? Well, there's kind of 3 things that you have to think about. One is security, right? So on your WLAN, you either have to create new WLANs or turn on WPA3 on those WLANs, which if it's enterprise, I think is very easy. If it's personal, the data shows people are really scared of that. Only 1% of WPA3 personal, out of all of our associations. But it's still doable, right? If you turn it on, the clients will connect. The other part is design, right? For 6 gigahertz, do you need additional, do you need a different design to support 4K QAM? Do you need a different design? Answer is maybe, maybe not. If you already have capacity-based design, then you probably are okay. If you've done a capacity design for 5 gig, probably okay. You may think about adding an AP here or there in like a conference room or physically to have line of sight because there's higher attenuation in 6 gig. And then from a network perspective, power and the uplink, right, from the AP. Most APs out there, Wi-Fi 6E, Wi-Fi 7 that have 3 radios need 802.3 BT power for full functionality. Now, most also have a reduced functionality on AT. So yeah, it's nice to have higher power, but not necessarily a requirement. Same kind of thing for MGig. With 3 data radios, you can potentially achieve over 1 gigabit per second in the real world outside of a lab. Will you do it every day? Probably not, but it's possible. And so MGig is a nice to have, not necessarily mandatory, but definitely a nice to have. I'll skip that one. Now, from a channel width perspective, I like this slide because, why is there why am I saying 6 gig, right? Why is it all about 6 gig? So there's a lot still to learn about Wi-Fi 7, but we know 6 gigahertz works today. And the thing that 6 gig gives you is the ability to use wider channels. So in the US, we're fortunate to have 1200 megahertz of spectrum. In Europe and UK, today it's 480 megahertz of spectrum, which is still very nice, right? It's an additional 5 gigahertz band. You've doubled your channels. And so what we see today is, again, looking across MIST, the average channel width, right? 59% have 20 megahertz configured, 40% have 40 megahertz configured. 40 is our default. So for somebody to use 20, that means they have to make a configuration change, which good people do. On 6 gig, we actually see a difference in channel widths between Europe and the rest of the world. So in worldwide, the most common channel bandwidth on 6 gig is 80 megahertz because a lot of countries have that 1200 megahertz of spectrum. But in Europe with the 480 megahertz, most people are configuring 40 megahertz, right? So there's an ability to use wider channels in 6 gig, which results in a faster speed test, which for the average user, that's all they know is speed test. They can see that number and say, hey, this isn't what I think it should be. Now, when you go ask them, what do you think it should be? They may not be able to tell you, but anyway, this is the primary reason, at least in my opinion, is clean spectrum, wider channels is the major benefit of 6 gig. We see clients with a strong affinity towards 6 gigahertz. So here is a network that configured 20 megahertz on 5 gig and 6 gigahertz. And this is the roaming history of a client. This client roamed about 300 times this day. This client was walking all over. And every single association for this client during the day was on 6 gig. Yeah, if you turn it on, they will go to 6 gig. And even more interesting, this is the history, like 2-week history in a network. So there's a lot of 5 gig clients, a lot of 5 and 6 gig clients, but almost 4,000 clients in this network only ever connected on 6 gig on an SSID that's offered on 5 and 6, which is pretty cool. Here's just some metrics. We're fortunate to have a customer that does an event, a one-day event year over year. So it makes for a really good benchmark. Starting in 2023, the 6 gig adoption was like, I think about 10% of clients on 6 gig. And these lines, the purple is the 5 gig data transfer, and the yellow is the 6 gig data transfer. And so if you look year over year, the 6 gig, the percentage or the total data transferred in 6 gig is increasing, sort of a lot. And even the total data transferred is increasing a lot. So yeah, there's more clients on 6 gig, more data transferred. It makes more sense. 5 gig is already at capacity. This is a university who did a deployment with Mist AP45s, which is a 6 gig capable AP. They had 5 gig turned on at first, and this blue line is showing the capacity SLE in Mist, which measures how much available airtime is there. And so they're at about 92-ish, 93-ish% capacity SLE, which for a network with 75,000 clients is quite good. At the end of a semester, this is actually almost a year ago now. So at the end of last fall semester, they turned on WPA3, make sure all is good, and then over winter break, turned on 6 gig. And so that flat line is the winter break, and then after the flat line is the start of the spring semester. Right away, they had like 25% of their clients connect on 6 gig, and the capacity SLE went up from the low 90s to the upper 90s. So like a 5% improvement in capacity SLE, which again, network their size is tremendous. Yeah, the 6 gig, gives you more capacity. The other thing is, if you look at, across a lot of vendors, not just Juniper Mist, there are new deployment options in terms of the capabilities on the access points. There's a trend right now to APs with built-in directional antennas and software controllable antennas, which gives you the benefits of a high density type of design with the simplicity of an integrated AP. So with that, takeaway is Wi-Fi 7 is cool, 6 gigahertz is cooler, and we're still learning about MLO. So you should get comfortable with WPA3. And last thing, come to our event tonight. We will have AI versus Wi-Fi engineers, see who wins, and we may also give an update on where we are with this acquisition. So come check it out. Thank you.